There are three phases of catching an object, and it's proportional to the percentage of ball flight time. So for example, in 25% of the ball flight time, the subject will begin to flex their elbow and extend the fingers. At 50% of ball flight time, the hand will be withdraw from the ball, so like this, and shape the hand to position the fingers. And at the last 75%, the final finger positioning, final adjustment of the finger positioning according to the ball size will occur at 75% of the ball flight. What this implies is that it's pre-programmed. The catching sequence is somehow pre-programmed, and in that vision provides advanced information. Other studies looking at vision in catching. The first study by Amazine, their hypothesis was from the ball juggling. So the comments you will hear when you practice juggling the ball, the experts might say you have to look at the peak of the ball flight. So focus on the zenith of each ball motion rather than looking at your hands or midway of the ball. So they wanted to identify if the subjects tune into that window of seeing the zenith of the ball. What I mean by that is the subjects were actually wearing the liquid crystal glasses. So this, what it does is it can block the view, so it became opaque and without distorting the luminance of the surroundings. So it becomes opaque, and you can program when it's to block the view in certain time. So what the Amazine and other colleagues did was they asked the subject to toss the ball, one ball, and like a juggling. So just toss the ball up and down. So the ball was moving up and down in one place. So that's the ball. And they were using the liquid crystal goggle. And they had different frequencies of opening and closing of the goggle. So they had the set frequency of opening and closing the goggle, and they just asked the subject, just toss the ball as the pattern you like. And what they found out that was when the goggle was opened, the subject would like to see the ball at the zenith. So they actually tossed the ball at the frequency of opening the goggle, which allows the subject to view the ball at the zenith. So the Amazine and colleagues concluded that it's the zenith, the motion at the zenith provides important information such as tau, time to contact when it falls, and the subject actually adjusts their action to perceive. Normally we perceive in order to act. In this case it showed we act to perceive. Is it right? Yeah, it's EI, sorry. So tau about the zenith was used for the timing of the catch. In a normal situation, when the ball is coming towards the subject and the subject has to catch, the tau information, the time to contact information, which is tau information, is crucial in catching. So just prior to contact, about 200 milliseconds to 300 milliseconds beforehand contact is critical, because in that window the subject can use the relative optical information, optical expansion information equal to tau. What about not just prior to contact, but during the initial flight and so on? And this Elliott and colleagues actually use the crystal goggle, liquid crystal goggle, and they just flicker the vision in that way. So they had different frequencies of flickering, so blocking and opening of the goggle, and they identify 80 millisecond intervals of off, so blocking of the vision, and 20 milliseconds of on. The subjects were still able to catch the ball, but if the intervals increase, like 100 milliseconds of off interval, the performance began to deteriorate. In the same on time. But even the 100 milliseconds, if they increase the on time, like for example 60 milliseconds, they were able to maintain the performance level. So in other words, viewing time, sufficient viewing time is important, crucial in catching, because in viewing time it can integrate the visual information to calculate the time to contact variables.